right, so 11-2 is on just basic probability. And there's three types that we'll look at: experimental, theoretical, and geometric. Experimental probability would be where you performed something. You rolled a die 20 times, you flipped a coin 30 times, you kept statistics on something, and you could then find the probability of favorable over total from what you did. Theoretical probability would just be, okay, think about it. What's the probability of rolling a 4? 1 out of 6. What's the probability of tossing a head? 1 out of 2. Like, theoretically, what should it be? Sometimes you flip a coin and you get head 5 times in a row. Does that mean you have a magic coin? No, it means that just your experiment, you got heads 5 times in a row. Okay? That's different than theoretical. So we'll just do a couple examples of each. A basketball player attempted 24 shots and made 13 of them. Find the experimental probability that a player will make the next shot she attempts. So probability, you should know, is favorable over total. So my probability here is what? 13 out of 24. And for probability, I will take decimal or percent. And the reason I say that is because if you tell somebody they have a 13 out of 24 chance, that doesn't make a lot of sense. But when you give them the percent, what's the percent? Point what?
542.
So if you tell someone they have a 54% chance of making the next shot, that just means more. Okay? So all of your answers today and in this chapter, probability should be decimal, or if you wanted to write it as a percent, you could do that too. But I would take either one of those, not fraction, just because it's not easily to visualize what that means. A baseball player attempted to steal a base 70 times and was successful 47 times. Find the experimental probability that the player will be successful on his next attempt to steal a base. So again, favorable over total would be 47 out of 70, which is what? 0.67. Good. 5 cards numbered 1 through 5. You choose one card at random. So for these questions, I like to write it out. 1, 2, 3, 4, 5, right? So out of these 5 numbers, these 5 cards, what's the probability that the card is a 2? 1 out of 5, which is 0.2. How about the probability that I get an even number? How many even numbers are there? 2, because 2 and 4. 2 out of 5, which is 0.4. What about a prime number? What are my prime numbers? 2, 3, and 5. 1 is neither. So that would be 3 out of 5, which is 0.6. How about less than 5? If I say less than 5, am I including 5? No. Less than 5 means less than 5. So that's 4, 3, 2, 1. So that would be 4 out of 5, which is 0.8. Okay, I have a bucket of pens, 15 blue, 35 black, and 40 red. You pick one pen at random. So what's the first thing I need to do in order to solve these problems? Add up how many pens there are. So 15 plus 35 plus 40 is 90 pens. Okay, so now what's the probability that I get a black pen?
35 over 90.
Yep, 35 black pens, so that'd be 35 out of 90, which is what is a decimal? 0.38. Oh, so 0.39. What's the probability of blue or red? So in this case, what's my favorable? Blue or red, so that'd be 15 plus 40, which would be 55 out of 90, which is what? 0.61. Good. How about not a blue pen? So if I'm doing not a blue pen, what's that? Black or red. So 35 plus 40 is 75 out of 90, which is what is a decimal? 0.83. How about black pen or not a red? What does that mean? Black or Blue, right, not red would be, take that out, so what's left? The blue. So that'd be the 15 blue, the 35 black, which would be 50 out of 90, which is what is a decimal? 0.56. Good. Probability, again, is just favorable area over total area. So here is my backyard, and I have a pool, that's the circle, the pool, and this triangle over here is my garden. So if I want to know what's the probability the ball, if I live next to a golf course and a ball lands in my yard, what's the probability the ball lands in the pool? So my favorable area would be the swimming pool. What's the area of a circle? Pi r squared. So what's my radius? 12. What's 12 squared? 144. So I have 144 pi over, what's the area of my whole yard here? Which would be 5,000, right? Length times height? Length times width? So favorable area over total area, you get 0.09, about 9%. The ball lands in the garden. Okay, so now I'm looking at my garden over here. What's the area of a triangle? Half of base times height. Yep. So half of, what's the base and what's the height? I'm going to do 1/2 times 8 times 6 over 5,000. What's that? Right? So half of 8 is 4. 4 times 6 is 24. So it's 24 divided by 5,000. So 0.005? Yeah. We'll say that, 0.005. Okay, so now, what's the probability the ball lands in the garden or the pool? Now think about this. If I want the probability of garden or the pool, and I already did the probability of the pool and the garden, what can I do to find that probability? Add them together. Because if I know I have a 9% chance of landing in the pool and a 0.5% chance of landing in the garden, and I want to know what's the probability of landing in either or, I can add those two probabilities together and say, oh, it's a 9.5% or 0.095 chance that it'll land in the garden or the pool. Okay. How about the ball does not land in the pool? Okay. Sometimes in statistics you can solve stuff by the complement. Complement means that if one thing happens, then there's only one other option. Like if there's a 30% chance of rain today, what's the probability of no rain? 70, because it either rains or doesn't rain. Okay? So if I look at this one, my probability, I either land in the pool or I don't. That's the only two things that can happen when I'm talking about the pool. The ball can land in the pool or it doesn't land in the pool. So if I have a 9% chance of the ball landing in the pool, what's the probability of not landing in the pool? 91. Those are called complements of each other. Sometimes using the complement is easier to solve than, and then instead of adding up, right, the area that's not the pool and dividing by 5,000. Would you get the same answer? Yes, but it's easier to use the complement. Talking about probability, in order to find probability, there's two things you need to consider: the sample space and the number of outcomes. Okay, so let's do a couple of examples first. If I wanted the probability of rolling a 6, okay, my sample space for rolling a die, rolling a 6, would be 1, 2, 3, 4, 5, 6. The number of outcomes would be 6, because there's 6 things that can happen. So your sample space is describing everything that can happen. Your number of outcomes is how many there are. So if I wanted the probability of rolling a 6, I would say 1 out of the 6. Okay. Another example would be, what if I was going to have 3 kids, right? Probability, if you had 3 kids, what's the probability that 2 of the 3 kids are boys? So to figure that out, I'd first need to find what my sample space is. So what are all the combinations of having 3 kids? You can have 3 boys. You can have 2 boys and a girl. You can have a boy and 2 girls. You can have 2 girls and then a boy. A girl, a boy, and a girl. What else? All girls, good. 2 more. What are we missing? Boy, girl, boy. And 1 more. What am I missing? Girl, boy, boy. Right? If I was going to have 3 kids, that's all the different ways I can have 3 kids, right? I have a boy first, then another boy, and then a girl. Okay? So how many outcomes are that? 8 outcomes, right? That's my sample space. How many outcomes is that? 8. Okay? So I would use both of these things to answer the question. What's the probability that 2 of my 3 kids are going to be boys? So, and exactly 2. So which ones have exactly 2 boys? 1, 2, 3. So I'd say 3 out of 8. 3 out of 8 probability, whatever that is as a decimal, of having exactly 2 boys if I wanted 3 kids. Okay. See the difference between sample space and outcomes? Okay, so let's do the example on our paper. A spinner shown at the right has 4 equal-sized sections. Suppose you spin the spinner 2 times. What is the sample space? So if I was going to spin the spinner 2 times, what's everything that can happen? I can get 1, 1, 1, 2, 1, 3, 1, 4. Then I can go 2, 1, 2, 2, 2, 3, 2, 4. 3, 1, 3, 2, 3, 3, 3, 4. 4, 1, 4, 2, 4, 3, 4, 4. That's my sample space. That's everything that can happen if I spun the spinner twice. How many outcomes is that? 16 outcomes. What's the probability then that I get a sum of 4? So what are all the examples of a sum of 4? 1 and 3, 2 and 2, 3 and 1. So that'd be 3 out of 16, which is what is a decimal? So 0.19, 19% chance of probability that you'll get a sum of 4.